Welcome. Let's take a look at an introduction to exponents, and we're going to do things in a fashion that hopefully this makes sense to you, and it's just not just a bunch of rules that we're throwing at you. So I won't stick to the method I'm going to use on this first problem long, but I do want to show you the visual I hope you get from these. So here we have 2 times 2 to the third, and we're not in this case looking for the final answer of this, which is 16. We want to represent this with exponents. So I'm going to represent the first 2 as 2 to the first. And excuse me, just had a little technical glitch there. And I'm going to rewrite this. 2 to the first means just a 2 times, but 2 to the third, of course, means 2 times 2 times 2. And if I'm going to represent this with the exponent, well, now it's pretty clear. I have a 2 and 3 more 2's. I have a total of 4 2's, and the common mistake would be, well, 4 2's, that's 8, but this is not 2 plus 2 plus 2 plus 2. It's 2 times 2 times 2 times 2, so 2 to the fourth. And quickly here, we probably expect to know a rule where we had 1 2 and 3 2's. We end up with 4 2's. We just do an addition there. So something to look at going forward. So to repeat that process, virtually the same problem here. What I would get as a common mistake on this would have something to do with 16. But let's take a look. This is 4 to the first, so a 4 times 2 more 4's. And what I have is a bunch of 4's. I don't have any 16's. I have 3 4's, 4 to the third. What I would see a lot of for this answer would be people would say, well, 4 times 4, 16, and 1 and 2, I know I add those 3. That's telling me you're memorizing things. You don't really understand what's going on. You're telling me there's a bunch of 16's here, and I'm saying, no, there are no 16's there. There are a bunch of 4's. So, not good. So now, I'm not going to write all of these out, but in my mind, I'm seeing it. I'm seeing this break into 6 4's, and I'm seeing this break into 6 4's, and I'm seeing this break into 6 4's. Now, 4 times 4 times 4 is 64, but I don't have any 64's there. I just have a big group of 4's. How many? I had 6 4's, and 6 more 4's, and 4 more 4's for a total of 16 4's. Easy enough. Okay, likewise, I have a whole bunch of 2's. 2 times 2 times 2 is 8, but I don't have any 8's there. I just have a whole bunch of 2's. I have 4 2's and 6 more 2's. And every time I see times, I'm thinking and 5 more 2's. And we realize all we need to do in this situation is we just add them up. Why, though? Because there's how many 2's, if we were to draw all of those out, would we end up with multiplied together? So in this case, we end up with 2 to the 15th, which is a surprisingly large number and not the common mistake, 30. It is safely into the thousands. Okay, now, little different appearance here. Common mistake here would be to say, well, we're supposed to add exponents and get 2 to the 7th. Other common mistake would be, well, if I take 2 to the 4th and I get 16 and then I take that to the 3rd, or do I take 3 plus? There's just a lot of options going on here, but it should be really, really clear. What does this mean? This means I have a 2 to the 3rd times another 2 to the 3rd times another 2 to the 3rd times another 2 to the 3rd. And now I have a whole bunch of 2's. I have 3 2's and 3 more 2's and 3 more 2's and 3 more 2's. You may even, and I won't do this very often, break this into all of the 2's represented here. Just to get a visual. Again, I wouldn't want to have to do that all the time, but it gives us a pretty nice visual of what's going on here. I have 4 groups of 3 2s. 4 groups of, and I look back at these parentheses and I say parentheses are also called grouping symbols. So I read these things with parentheses from the outside in and I say I have 4 groups of 3. 4 groups of 3 what? 2s. Well, 4 groups of 3 implies multiplication. So that is 4 times 3 or 3 times 4. I get 2 to the 12th, which is most certainly not 24. Much, much bigger. Let's see. It's over 4,000. So how do we read this? I read from the outside in. These are parentheses, but I'm thinking groups. 3 groups of 2. If I have 3 groups of 2, I have 6. 6 what? 6 3s. So our rule, and a lot of people say, well, an exponent raised to an exponent. Sometimes I multiply, then I have exponents and exponents. Sometimes I add. I want you to see that visual picture. I want you to, at least in your mind, picture this as 3 groups of 2 3s. That's why we're coming up. That's where we're coming up with 6 3s from. We don't want to work with rules that don't make sense to us, so we read this from the outside in. 3 groups of 2. 3 groups of 2 is 6. 6 what? 6 4s. 4 to the 6th. Okay, mixture here. If I was to write this out, I would have a 4, I would have 4 ends, I would have a 3, I would have 2 ends. One point I want to make at this time is that exponents, I like to say exponents, are lazy. They are not going to do any more work than they have to. In other words, this 4 is not extending to that. There is just one regular plain old 4 here. And then, so if I was to write this out, this would be 4 times 4 ends times 3 times 2 more ends. And now it's pretty easy to see what we have. I have a plain old 4 times a plain old 3, 12, times a bunch of ends. How many ends? 1, 2, 3, 4, 5, 6. But take a look. What did I do? I added the exponents. Do I have 2 groups of 4 ends? No, I have 4 ends right here and 2 more ends. I got a bunch of ends, but it's 4 and 2. 4 ends and 2 more, 6 ends. Okay, so we end up 12 n to the 6th. Exponents are lazy. You'll see that come into play most of the rest of the way. So, very, very similar. This 2 is not affected by that 4. If I wanted the 2 affected by the 4, it would have been written 2x, all of that to the 4th. But that 4, that exponent is lazy. It's not going to overextend. He only has to work on the x's. So I have a plain old 2 times a plain old 6 times a plain old 3, and then I got a bunch of x's. I'm just going to group my x's. I got 4 x's and another single x and 4 more x's. Bad 4. So I end up with 2 times 6, 12, 12 times 3, 36, followed by a bunch of x's. Do I take 4 times 1 times 4? Or 4 plus 1 plus 4? Well, do I have groups of? This is not 4 groups of 1 group of 4. This is just 4 x's and 1 x and 4 x's for a total of 9 x's. 4 plus 1 plus 4. Okay, so once again, this 5 does not affect the 3, only affects the x. The x is said to be 5's, the exponent 5's base. So we have a 3, and we have 5 x's and 4 x's. 3 and 9 x's. Very, very simple. Okay, I put this one on here just because sometimes people struggle with the whole no exponent thing now, but there's always an exponent behind everything. If it's not there, it's an implied 1. So in this, I have a 4 times a 3 and a single n times a single n. Of course, n times n is n squared. Okay, so you're saying pretty simple. Well, you're going to see things start getting a little bit more complicated here. In this problem, I have two groups of 5p to the third. You may, for a while, want to write this out because it's something new. That's 5p, p times 5p, p. So that is 5p to the third times 5p to the third, or 5p to the third squared. So what do I end up with? I just end up with a 5 times a 5 and a bunch of p's. How many p's do we have? 6 of them. Whoops, didn't want to do that. So there we go. So what we notice here is this 3 only affected the p's, but this 2 has to affect the 1 5 that's in there and the 3 p's that are in there. Two groups of 1 left us with 2 5s. Could have written it like this. And two groups of 3 p's left us with two groups of 3 6. So these are equivalent. We would probably simplify when the numbers are as small as this. We're not dealing in the thousands at this point. Okay, so go ahead and try this one. I'll give you a head start, or you can pause the computer. I'm not going to raise that 5. I'm not going to take 5 to the 5th power and figure out what that one is. I'm just going to leave exponents in my answer. So this is a single 5. The 3 does not affect that 5, but this 5 does. So I have 5 groups of 1. 5 groups of 1 is 5. I have 5 5s. And I have 5 groups of 3. 5 groups of 3 is 15 x's. And again, depending on what the question asks for, maybe we'll go to our calculator and take 5 to the 5th, but I'm going to leave it in that form. 5 to the 5th, x to the 15th. Likewise, a single 3 here. 3 groups of 1 3. 3 times 1 3, so that is 3 to the 3rd. 3 groups of 1 is just 3, a group of 6. 3 groups of 2, though, would be 6. 3 to the 3rd, r to the 6th. We may want to find 3 to the 3rd. Don't make the common mistake. We've all seen it. We've all done it. 3 to the 3rd is not 9. That's what 3 times 3 is. 3 to the 3rd is 3 times 3 times 3. 27 r to the 6th. Okay, now things might get a little more challenging. And obviously our eyes are drawn to those negatives first because we haven't had one yet. And I would typically question a class here and say, how many negatives are there in this problem? And the first time I question it, maybe the first, second, third time I ask the question, most students are going to say there are 2 negatives here. But there are not 2 negatives. As lazy as this exponent 4 is, that 4 affects the 6, but also has to affect the negative. So there is a negative here, but there are 4 negatives here, giving me 5 negatives multiplied together. Well, if we have an odd number of negatives multiplied together, I know my final answer is negative. And now I am done dealing with negatives. Everything else, they're done. I've taken care of them, the 5 negatives together. So now I'm really just looking at this kind of like this. I've taken the negatives out. They are done. So I end up with negative. I've got a 6 and 4 more 6s. I don't have 4 groups of. Four groups of 1. I have 1 6, 4 more 6s, 6 to the 5th. So negative 6 to the 5th. So the big key there is how many negatives do we have, and that's going to be what I want you to focus on as we move forward here. So how many negatives in this problem? Had I asked you this before we went through here, I think everyone would have said 1. And now I ask, and I think some people may say, well, maybe there are 4 negatives because of this. But don't forget, exponents are lazy. This 4 is only required to cover the x, not the 4 and not the negative in front of it. So this problem has 1 negative right here. Therefore, my final answer is negative, and I'm done dealing with negatives. From this point on, I might as well just ignore that guy. I've got a 2 times a 4, 8. I've got 1x and 4 more x's, x fifth. That is the most likely mistake, though. Just like pretty much all of Algebra 1, the most common errors occur with handling negatives. Don't make the common mistakes. So again, here we have one negative, problem very similar. Just a single negative. This 2 only affects the ends. So with one negative in this problem, my final answer is negative. I'm done with you. I have a 4 times a 4, 16. I've got 4 ends and 2 more ends for a total of 6 ends. I don't have 2 groups of 4 ends and 2 ends. Wow, how many negatives here? Well, if I just look in here, there's 1, but if I let this 4 do his thing, there's 4 of them. But this 3 has to come in there as well. Let's handle this one this way. I have 3 groups of 4 negative 4s. 3 groups of 4 negative 4s. So 3 groups of 4 is 12. How many negatives does this problem really have? 12 negatives. As lazy as this exponent wants to be, it's told it has to handle the 4 and the negative. 12 negatives is a positive. 4 to the 12 groups of 1, 12. So positive. Okay, a little bit of break from that. But as lazy as the 2 wants to be here, it has to affect the x's and the 6's. How many 6's are in here? Well, the 5 is lazy and only affects the x. So there's a single 6 in here. Read it from the outside in. 2 groups of 1, 6. 2 groups of 1 is 2. So a pair of 6's multiply together. And 2 groups of 5 x's, 2 groups of 5, 10. So either this or 6 squared, 36, x to the 10th. And if I ask negatives here, does this 2 affect the negative? Well, what's our rule about exponents? Exponents are lazy. That 2 has to affect the p, but not the negative. But does this 4 affect the negative? Yes, no choice but to affect the negative and the p squared. So we have 4 negatives. 4 negatives, even number, final answer is positive. And then read from outside in, 4 groups of 2 p's. 4 groups of 2 is 8. A lot going on, but this is simpler than some with all the negatives. I only have a plain old 2. I only have a plain old 5, so I'm going to multiply those. 2 times 5, 10. I'm going to take a look at my x's. I've got 5 x's, and that's it. Multiply together y's. I have 4 of them and 6 of them, or do I have 6 groups of 4 or 4 groups of 6? Nope. I have 4 of them and 6 of them. A total of 10 y's. Likewise, plain old 6, plain old 5, 30. X's, 2. Y's, 3 and 6. That's not 6 groups of 3, that's 3 y's and 6 y's, total of 9 y's. Should be pretty simple. Okay, this 4 only affects the u, this 4 only affects the v, but this 4 has to affect the 3's. There's one of them. The u's and the v's. So outside in, 4 groups of 1, 3. 4 groups of 1 is 4. 4 groups of 4 u's. 4 groups of 4, 16. 4 groups of 4 v's, 16. Again, how many 2's are there? 1. How many y's are there? Are there 4 y's in there or 1 y in there? Exponents are lazy. 4 only affects the x. But this 3 has no choice. Affects the 2's, the y's, and the x's. So that is a bunch of 2's, 3 groups of 1, 3, 3 groups of 1y, 3. 3 groups of 4 x's, 3 groups of 4, 12. We may want to take 2 to the third here. 2 times 2 times 2, 8. Y to the third, x to the 12th. And that wraps up that lesson. Hope that's helpful for you. Stay tuned and good luck.